Please be bear with me for 5 minutes. Okay, success. An error occurred. Please try again. Oh, क्या हो गया यार? Again, bro. Again, it's a problem. Look at here. There is a problem. But it is showing live stream. But I don't know what I want to do. हाँ, check करो एक बार. How are you all? Jamie, Bellary. How's the environment condition there in class? COVID cases बढ़ रहा है ना? हाँ, it's not coming bro again. किधर? चेक करो एक बार. I'm trying to do something here, but क्या है?
ये आया है आपका
आया क्या?
जाके दिन को पढ़ा
Yes, पूरे vertical आपको. तो बात है. My voice is also correct.
जूम पे जाओ उसको वहाँ पे बैक कर देना
Now it is live, no? Check the
हाँ
bones. What is the problem? Yes, thank you guys for bearing with me here. Okay, good evening to everyone once again. Let me know, guys, whether I'm an audible and my screen is visible to everyone properly. Do text me in the chat box quickly. Janvi Bellari. Yes, outstanding. Outstanding. Text. Yes, thank you, Akshita. Thank you, guys. Okay, sorry for that inconvenience. Actually, I came late today also. Okay, yesterday we started with the refraction topics, right? In ray optics. Today we are going to learn about few more topics which are regarding about the refraction. First one is Snell's law. Actually, what we learned in a mirror met two laws we studied. No, similar way we need to study two laws under the refraction. Okay, under this refraction we call this law as an Snell's law. Okay, later on we have to know about the what is the meaning of refractive index, and later on I will talk about the real depth and apparent depth kya hai, and also what is the relation between the real depth and apparent depth with respect to the refractive index. Okay, these are all the things which I'm going to discuss in today's class. Okay, now before that, let us take a quick recall what we discussed in a previous class. In previous class, I started with the refraction. Before that, I solved few numericals. Okay, refraction kya hota hai actually? Bending of light around bending of light when the light which is coming from one medium to another medium. I given a best example for this one also, right? Which we can identify in our daily life also, right? If you keep a pencil or pen, or if it is not possible, if it is not available at the moment, means keep your finger inside the bowl which is containing some water. At the surface where the water and as well as the air which is separated, at that portion you will looking like the object which you kept inside there, it will be look like a bent. It is just because when ray of light which is coming from one medium to another medium, it will not follow the straight path. correct now? Straight path will not follow by the light, hence this object will looking like a bend. Clear? This is the basic for the refraction. Later on we know the, we actually I explained the ray diagram for the refraction through by using one glass slab, correct now? This is a glass slab. Just imagine, this is what the incident ray, when incident ray will be incident on the glass slab surface, first surface, okay, actually it has to go in this path, has to followed by the incident ray, but due to the change in medium, the ray which is bent towards the normal and travels straight, correct now? And again for the surface CD, this refracted ray now, it will act like a incident ray again. From the glass medium to air medium, again it has to come now, light at this moment it will move away from the normal. Clear? This is what the condition which we discussed in our last class. And also we call this ray as an emergent ray. This emergent ray is to the incident, extended incident ray. Clear enough, right? Okay, cool. Next, later on we discussed about the deviation angle. Deviation angle क्या होता है? Deviation का मतलब क्या है guys? Actually look at here, this is the light direction. Actually when it is incident on a medium, it has to move in this direction only. But to the change in this medium, the ray will be bent. इधर क्या हो गया? Deviate हो गया, correct ना? That is known as the deviation. इधर एंगल पता करना है deviation के लिए with respect to the incident extended ray to refracted ray, correct? Deviation angle. Yesterday we find the deviation angle when the ray which is coming from air medium to denser medium, means a water medium. At that condition we find the deviation value as an delta is equal to I minus R. Similarly we find out the deviation angle for the ray of light when it which is coming from denser medium to rarer medium, that is R minus I over R. Clear? These are the things which we discussed in our last class. If you have any doubt, means please do let me know in a chat box quickly. Team Ballari, Davangere, Darshan. Is it clear? No? Yes. Good. Next, if it is no means I have one question here. Right? The question says like that: the ray of light refracted in rarer medium. It is refracted in rarer medium. Then the ray moves dash. Which is the correct option among this following questions? Hey, super. Those who are given an answer, no, for them from my end, just surprising gift. क्या है? दर्शन, 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 क्या आंसर दे रहा है यार? कोई तो प्रॉब्लम नहीं, करेक्ट ना? इधर एयर मीडियम में रिफ्रैक्ट हो रहा है, राइट? मींस वी नीड टू कंसीडर रिफ्रैक्शन. रिफ्रैक्शन मींस इधर फेनोमेना हो रहा है एक्चुअली. दिस इज अ, इफ यू कंसीडर the denser medium, the rarer medium. Denser है water, rarer है air. Now refraction हो रहा है किधर? Air medium में. Means any ray of light which is incidenting in a traveling in a water medium, incident on the surface AB. Okay, at this surface you are going to draw one normal like this, correct now? Now actually light has to go in this path, correct? But due to the change in medium, this is a rarer medium. Now the ray will be moved away from the normal, and as well as the whatever the incident ray है ना, ये incident ray के ज्यादा क्या होता है? Bend होता है. Means hence the correct answer is bend. Sorry, bend away from the normal. B is the correct answer, guys. Correct ना? Is it right? थोड़ा सा क्वेश्चन थोड़ा सा उल्टा दिया था इधर. Cool. प्रॉब्लम. रेयर और मीडियम में रिफ्रैक्शन हो रहा था. ओके, कोई तो प्रॉब्लम नहीं. विल बी मूव. यस. ओके, स्नेल्स लॉ क्या बोलता है? राइट, रिफ्रैक्शन में इंपॉर्टेंट थिंग है स्नेल्स लॉ. एक्चुअली वी ऑलरेडी टोल्ड यू नो in mirror we studied two laws, right? That is the angle of incidence equals to angle of refraction, right? In a similar way here also Snell is a scientist. He given a first law like this: sine of the angle of incidence, the ratio of sine of the angle of incidence to the sine of the angle of refraction is equal to a constant value. Correct? This is what the statement which is given by the Snell. क्या होता है इधर एक्चुअली? इधर रे बेंड होने के लिए फर्स्ट रीजन है स्पीड डिक्रीजेस. क्या होता है? स्पीड विल decreases. That's why it will be bent. Based on this concept, based on this particular word, he given a law like this: ratio of sine of the angle of incidence to the sine of the angle of refraction is equal to a constant value. एक constant value को हम बता दिए इधर, sin of incidence by sin of refraction is equal to mu. क्या है mu? Mu represents refractive index. क्या है? Refractive index. ये refractive index है, क्या है, सब कुछ बताता है. Okay, no worries. Now at this condition just you know that first law क्या होता है, क्या बोलता है इधर? The ratio of sine of the angle of incidence to the sine of angle of refraction is equal to a constant value. We call this constant value as an mu. Clear है ना? Or else if you want to notice this one with a specific word means we can write the mu value like this. इधर refraction हो रहा है, ये तो air medium है. This is the, just consider this is a glass medium. Okay, now we can write this one like this: refractive index of glass with respect to air. Right? इसको कैसे बोलता है? Refractive index. Short form में I will write this one in a short form: refractive index of a glass with respect to air. Refractive index of glass with respect to air. Clear now? We can write this one in a ratio form also. How to write this in a ratio form? Look at carefully. Mu of G with respect to A can be written as mu G upon mu A. Clear? Actually, this mu G by mu A is nothing but mu G of A. It is nothing but sine of the angle of incidence by sine of the angle of refraction. Correct? Now we can write here, we can equate this one like this: sine of the angle of incidence to the sine of the angle of refraction. Clear है ना ये बात? We can write like this also, or else you cross multiply this one. If you want to cross multiply means you will get an answer mu G sine R is equal to mu A sine I. This is also called the Snell's law. We call this one as an Snell's law. Clear? Is it clear? Guys, do let me know through the chat box. Yes. Yes, good. Good. Next. Yes, good. Next thing is that refractive index. मैंने बोल दिया ना इधर क्या था, एक फर्स्ट लॉ क्या था एक्चुअली, सेकंड लॉ आई विल टेल यू हियर इटसेल्फ. लुक एट हियर गाइस. फर्स्ट लॉ क्या था? द रेशियो ऑफ sin of the angle of incidence to the sin of the angle of refraction is equal to a constant value. This is the first law of the refraction. Second law क्या है? Look at here. This is the incident. This is incident ray. It will incident at this point. I'm going to call A, right? From this point only, the ray will be get refracted along in this direction. Correct now? Now, if you draw a line at this point of incidence, this is become normal. Look at here. This all are lies in a same plane. Same plane क्या होता है? Reflection में बता दिया था ना. This here 3 dimension. Just I will explain. This is the incident ray direction. This is a normal. This is what the reflection light, right? If you're going to see all these things from this end like this, okay, all 3 lines will be in a same line. You can't able to look. You can easily identify. You can't able to easily identify the line which are present behind this reflected ray. From this end, if you're going to watch means they are in the same plane. Similar way, here also, if you're going to watch this one from this end means incident ray, you can easily watch here because the reflected ray will be in another direction, no problem. But they are in same plane. Plane होता है ना, same plane में होता है. Second law will be same as like a first law. Okay. Second law of refraction is same. To which one? Second law of reflection. क्या बता दिया इधर मैंने? Instead of writing this one, I can write the law itself. No problem. Correct now? First law है sine of the angle of incidence to the sine of the angle of refraction is equal to a constant value. We call this constant value of a refractive index. Okay. Second law बताता है the angle of the incident ray, the normal ray, and the refracted ray all are lies in a same plane. They are lies in same plane. This is the second. Good. Coming to the point, refractive index. A refractive index क्या है? Actually, just listen, guys. In physics, may whatever the word will become no, they are normally available in a dictionary. Here also same. Either first word है refractive, second one है index. Actually, index क्या बताता है? Index बताता है numerical value. Correct ना? Numerical value को बताता है. Right? Refractive means here it is taking some phenomena, refraction. Right? During this refraction, just imagine what will be happen. I will tell you. When ray of light is coming in a air medium, it has its own speed. We know that speed will be 3 into 10 to the power of 8 meter per second. Correct now? Now, the same if it is entered to the denser medium. The denser medium, consider it's an water. At this moment also, is the speed of light having the same magnitude? Let me know through the chat box. Is the speed of light है ना? Is it having the same speed in water medium also? No, obviously, right? Because here refraction हो रहा है just because of changing in speed. Correct now? That's why here the speed will be, maybe magnitude will be changed. 10 to the power of 8 meter per second will be same. Correct now? ये change होने के बाद में what are the change will be takes place with respect to air and as well as water, right? If you're going to calculate that one means we will get a numerical value, that is an index that is represented by the refractive index. I will explain you through an example. Listen carefully here. इधर 10th standard में आप पढ़े थे, refractive index को कहता है speed of light in vacuum to the speed of light in any medium. Correct ना? C by V. Speed of light in C vacuum कितना होता है? 3 into 10 to the power of 8, 10 to the power 3 into 10 to the power of 8 meter per second divided by, if it is comes to any medium को आया है, now its speed will be reduced. I will write this one just for example, 2 into 10 to the power of 8 meter per second. करेक्ट ना, इधर 10 to the power of 8, 10 to the power of 8 कैंसिल हो गया, मीटर पर सेकेंड कैंसिल हो गया. व्हाट इज द रिमेनिंग थिंग हियर? क्या वो मिल गया? 3/2. इट इज नथिंग बट 1.5. look at here, magnitude only we got, there is no unit. Correct now, if the unit is not there means there is no dimensional formula, there is no dimension also, right? We got only the indexing value. Indexing value hai na, if it will shows that how much the change of speed will be takes place with respect to the two medium. Are you getting my point? This index value shows that how much speed value changing with respect to medium. करेक्ट ना? इसको रिप्रेजेंट करने के लिए हमको एक फिजिकल क्वांटिटी चाहिए था. That physical quantity we are representing with a letter mu. I hope now you got an idea about the refractive index. Correct? The refractive index is nothing but how much the speed of light will be changed when it is enter from one medium to another medium. इसको represent करने के लिए एक physical quantity चाहिए था हमको. We generate that physical quantity as a mu. That is the refractive index. Clear? Is it clear? Akbar, Akshita, Darshan, Jamie, Ballari. Yes, right. We'll move to the next point. Yes, good, good. Akbar, which school from you are? Note on this one. Good. Okay, fine. Okay, it's fine. Coming to the next point. Next point है refractive index में two types होते हैं, right? ये क्या टाइप होता है सर? इंडेक्स तो इंडेक्स ही है ना. इसमें टाइप्स किधर से आता है? No problem. We have to study about the two things here. First one is absolute refractive index. Second one is relative refractive index. The absolute refractive index क्या होता है? I will tell you first. Just imagine this is an glass slab. ये क्या है? Glass slab है. Okay, glass slab I kept in a air. Don't ask सर एयर में कैसे स्टैंड होता है? इसको एक स्टैंड भी चाहिए ना, right? Don't be asked like that. Just imagine it is present on a table. Okay, हमारा नन्ना सा मुन्ना सा टेबल भी है इधर. क्लियर? ओके, ग्लास स्लैब इधर है. ये टेबल भी ट्रांसपेरेंट है. ओके, when a ray of light which is coming in the air, if it is incident on the glass slab means क्या होता है? Obviously refraction होना चाहिए. Like this is the incident angle, this is what the refractive angle. Correct now? This is a normal. Now guys, in air speed of light I'm going to take a c. When it is enter to the glass slab, इसका velocity क्या होता है? v. I'm going to take this one like this. Now we need to compare the velocities when it is in air to the actually I'm not going to take this air as a medium. Just we need to consider air or vacuum exits for the absolute refractive index. Okay, we need to compare standard one. That's why. Now, if you write the refractive index for this one, we will go to write mu is equal to speed of light in air. This is the speed of light in air, or else you may take this one as a vacuum. Vacuum may should be there. In space, you can take. There to refraction which is takes place in atmosphere, it is very less. Okay, that's why we are considering here air as it is, because air molecules also transparent molecules, no, transparent, and refraction will be takes place in air molecules very less amount. Okay, that's why we are writing the refractive index value for air around 1.0003 for the air, and the same time refractive index for the oxygen molecule O2 co 1.00027. This is what the refractive index. Almost all in a vacuum, if you're going to take means it is exactly equal to one. Correct? Now, that's why I took here speed of light in air or vacuum to the speed of light in a medium, C by V. Right? This is known as the absolute refractive index. Here I'm comparing the speed of light with respect to the vacuum to the glass slab, right? That's why I'm going to express this one as an absolute refractive index. Clear ना? Absolute refractive index क्या होता है? Either I want to explain the refractive index of a standard one with respect to the medium. That's it. Now, if you write this refractive index mu value, it's an, if you're going to consider it's an air means it is refracted in glass medium. That's why we can write this one as an mu g with respect to A is equal to C by V. Practice this one, guys. Okay. Writing skill को increase करना है इधर. Mu g with respect to A means refractive index of glass with respect to A. If you want to write this one in a ratio means you need to write like this mu g upon mu A. Clear है ना? This is what the absolute refractive index. Coming to the relative refractive index. Relative refractive index क्या होता है? इधर देखो. ये तो वाटर है. ओके, ये तो वाटर है. ये क्या बन गया? दिस इज वाटर गाइस. पॉन्ड था, पॉन्ड के अंदर क्या है? वाटर है. Now I'm going to keep inside this water one glass slab. What is this? This is glass slab. Okay, now I mean imagine now I'm considering the ray of light from the water surface downward direction like this. A ray of light which is incidenting on the surface of a glass slab at the surface AB. Okay, either the speed of light कितना है मुझे पता नहीं. I'm going to call this one as an V1 because in air the speed of light है क्या है? C. It is what the standard. Correct now? Here I don't know. And when it is enter to the glass, refraction होता है. It is refraction again here means इधर इसका velocity और एक बार कम हो गया. Means here it's the velocity है V2. So no, right? इसका velocity है V2. Now we need to write the refractive index in terms of relation. Relation में कैसे लिखना है? Now I will write the refractive index value glass with respect to water. This is water, no? This is glass. सुनो. Glass के we need to write the refractive index glass with respect to water. That is what the relation which is giving for the refractive index. That's why we call relative refractive index. That's it. Clear enough? How to write this one? Here we need to write the refractive index of glass with respect to water, right? Then it will be equal to first. What is that? How to write this in a ratio form? Mu g by mu a is equal to mu g में कितना है velocity? V2 divided by mu a में means water में V1. Correct? This is what the relation which gives the relative refractive index. Either the velocity which is directly proportional to that medium. So no, the velocity which is directly proportional to that medium only. Keep this one in your mind. If you want to, in some books or modules or anywhere, they will give like this. Actually, I took like this, mu g by mu a. Correct now? They might be give like this, mu 2 by mu 1. Here, mu 2 represents the refractive index of the second medium. Mu 1 represents refractive index of the first one. Right? Is equal to now same equation. V2 upon V1. They'll give like this also, guys. Okay, दोनों सेम ही होता है. There is no change. ये दोनों equation सेम ही है. Now let me know. Is there any doubt? Hope it is understood, right? Note down. Meanwhile, is there any doubt? Ballari, in which point you have doubt? Yes, Akbar. Good. Yes, yes. Okay, shortcut. मैंने बता दिया था ना इसलिए. Jai. Okay, we'll move to the next slide here itself. We got here absolute refractive index के लिए value. Just a minute. हाँ, mu के लिए mu is equal to C by V. Correct ना? And one more thing, guys. ये mu के लिए there is no SI unit. It's an unitless constant, and as well as no dimensional formula. Dimensional formula. Okay, coming to the relative refractive index. Relative refractive index में क्या बता दिया था मैंने? Mu g with respect to water or mu diamond with respect to air. क्या? It is dependent on the problem. Okay, it can be written as mu g upon mu a is equal to V2 upon V1. Means velocity. We can write this one like this also. Velocity in a glass medium to the velocity in a air. Okay, सब कुछ same ही है. There is nothing change. And what here the refractive index will be depends on few important parameters. What are the first one is nature of the media of two incident and refraction. Okay, where the light is incidenting on that medium, the refraction is depending. Suppose, listen here. Okay, this is air. This is air. This is water. ये क्या है? Water. Second case में, this is the first case. Second case में, this is the first case. Second case में, I'm going to take air. This is glass. Guys, let me know. Compare air का refractive index same ही होता है दोनों तरफ. Comparatively, glass and as well as water में, which one having a denser medium, more denser? Let me know through the chat box. Glass, water, which is more denser? Which is more denser? Yes, of course. Glass is more denser. Correct ना? इसलिए if I'm going to just a minute. If I'm going to introduce any incident light on this medium, water medium, okay, it will bend this much itself. Okay, this is the angle of refraction. If I incident a same ray in a same angle for the second scenario, okay, but here refraction angle क्या होता है? बहुत कम होता है. ज़्यादा refraction होता है, refraction angle बहुत कम होता है, because it is depending upon the medium. पहला condition true होगा. Next one, color of light or wavelength of light. Yes, color of light में depend होता है. Why it is depending upon the color of light? I will explain you. Just note down this one. I will explain you this topic when we are dealing with a prism. Prism में refraction होता है ना, and that time I will explain why it is depending upon the color. Okay, If I start here itself means it will be disturbed. That's why I won't start that one. Clear? Next thing है temperature में depend होता है. If the refractive index decreases means with increasing in a temperature. Temperature increase करने से refractive index क्या होता है? Decrease होता है. Okay. On these three factors, the refractive index is dependent. Clear? First one है nature of the medium. Second one है color of light which is incidenting on it or wavelength of the light. Third one is temperature of the medium. Okay, if temperature increases, refractive index decreases. Clear? कल तो क्लास होता है क्या? I think tomorrow is holiday, right? If there is no holiday means I will let you know. Yes. Oh, they are eagerly waiting for the holidays. Good. Good. Coming to the next one, principle of reversibility. Principle of reversibility. ये क्या कहता है principle of reversibility? Listen. सुनो इधर. ये है दो मीडियम है. First, second. Actually, ray of light is incident in a first medium. Just consider this medium as an air medium. Okay, this medium where it is incidenting. No, at the point if you're going to draw the normal, if you're going to draw the normal means from that point onwards, the ray will be get refracted like this in this way. Correct? Now, this is the direction of refraction. Correct? This is the ray direction of refraction. If I'm going to keep one mirror, क्या है ये? Mirror perpendicular for the incident ray means making an angle 0 degree. Making an angle 0 degree like this. If I'm going to place one mirror means क्या होता है? Again, the ray which is incidenting on the mirror, it will retrace as the path as it is where it will be come from. Correct? Now, to the same path it will be travel. This is known as the principle of reversibility. A principle of reversibility में guys, one question will be maybe question will be arrival here. Okay, कैसा पूछता है हमारा question? सुनो इधर. Now, first medium से second medium light is entering. No, yes, keeping plane mirror. हाँ, reverse होना है means we need to keep on plane mirror. Reversibility है ना इधर. That's why. If it is not reversibility means we can understand this topic in another mode. How? I will explain. This is the ray which is in refracted. Okay, in reverse order we need to understand this one, right? We can't able to understand like that. That's why I kept here one mirror. River का तो mirror. River mirror. ये क्या है? Sibling words है ना? Okay, cool. Now, air, this is what? Water. Correct? How are you going to write the refractive index for this one? By applying Snell's law. By applying Snell's law. Snell's law को apply कर रहा हूँ मैं. कैसे? देखो इधर. Mu, water with respect to air we need to write. Water with respect to air. इसका full form कैसे लिखना है? Mu W by mu A, right, is equal to sine of the angle of incidence to the sine of the angle of refraction. कब हो गया ये? When ray of light incidenting in a air medium refracted at water medium. At this situation we got equation number 1. Now second case है क्या है? This is from medium 1 to 2. Now reverse क्या होता है? Medium 2 to 1. Medium 2 to 1 means how to write the Snell's law here? Refractive index of air with respect to water is equal to mu A by mu W is equal to इधर sin of the angle of incidence लिखना है. एंगल ऑफ इंसिडेंस क्या होता है, इधर से r होता है, देन इट विल बी साइन ऑफ द r डिवाइडेड बाय रिफ्रैक्शन एंगल मींस एमर्जेंट एंगल क्या होता है, साइन ऑफ एंगल ऑफ इंसिडेंस होता है. आई एम गोइंग टू कॉल दिस इक्वेशन नंबर 2. नाउ व्हाट आई विल डू, नो जस्ट आई विल मल्टीप्लाई दिस टू इक्वेशन. ये दोनों इक्वेशन को क्या कर रहा हूं मैंने, मल्टीप्लाई कर देता हूं, left hand side and as well as right hand side. To write in a short way, I'm going to take the refractive index, this two. Okay, multiplying equation 1 and 2. क्या होता है, mu W with respect to air, refractive index of water with respect to air into refractive index of air with respect to water is equal to right hand side में क्या है, sine of the angle of incidence by sine of the angle of refraction into second one है sine of the angle of refraction divided by sine of the angle of incidence. ठीक है ना. now this sin I cancel, sin r cancel हो गया, remaining क्या है, 1 हो गया. then this equation can be written as mu of water with respect to air into mu air with respect to water will be equal to unity. Guys, this is very important topic. Actually, JEE में पूछता है एक property को, but here we took only 2 medium. They might be asked the question with respect to 4 mediums or 3 mediums. Okay, but when we are going to multiply the or find out the refractive index of 3 medium, 4 medium anyway, okay, we will get the value in unit. मीन्स ये क्या किसको इक्वल होता है, 1 को इक्वल होता है, कब, प्रिंसिपल ऑफ रिवर्सिबिलिटी है. मिरर शुड बी परपेंडिकुलर टू द रिफ्रैक्टिव रे. हाँ ब्रो, प्रिंस रिवर्सिबिलिटी मीन्स in the same path we need to send the ray, means we need to keep this mirror exactly perpendicular to for the incident ray direction. Correct now, that time only it will retraces its original path like this. If it is a source means source से आता है, refraction होने के बाद mirror के ऊपर incident होता है, again it will be reflected in the same way and again it will be traces the ray path. That's why Akbar we need to keep this one in a perpendicular. Clear है ना bro? Is there any doubt guys up to this point? Let me know. कैसा लग रहा है क्लास, अच्छा है ना, calm, cool. Is it okay, JNV Ballari? Hey, super. May I know who is chatting with me here, Ballari team से? Hey. Your name bro, may I know your name? Don't write everybody's name. Nandish. Hi, Nandish. Thanks, bro. You're giving an excellent reply here. And while guys, please do participate in a NPS poll also. I'll launch this NPS poll. Just listen, guys. What my your chemistry teacher is saying. No, I think you know Gopi sir, right? He's saying like NPS of NPS ಗೋಸ್ಕರ ಎಷ್ಟೆಲ್ಲ ಕೇಳ್ಕೊಳ್ತಿದ್ದೀರಾ ಅಂತ ಹೇಳ್ತಿದಾರ. No, yeah. Okay, cool. Yes. We'll do this one today. Lateral shift. Lateral shift क्या होता है actually? Bro, check करो एक बार आपका जियो5 क्या कहाँ है? It is connected with the जियो5. हाँ, yes. Lateral shift क्या होता है? Refraction में we are going to analyze the lateral shift in refraction pattern. Okay, just imagine this is one of the medium. Which medium? Blue color है, पानी blue. Correct ना? ये तो water medium. We'll take like this water medium. Correct ना? when a ray of light which is incidenting on a water in an oblique incidence, it is an oblique incidence, is an incident ray. क्या होता है? At the point of incidence we need to draw a normal. Actual path था incident ray का, this is what the actual path. I'm representing in a red color a shirt. I don't have a scale. How to draw this one? I don't know. This is what the actual path which has to travel by the ray of light. Correct now? But due to the change in medium, this is the air medium, this is what the water medium, right? The ray will be get deviated towards the normal like this. Correct? Refraction ray is the angle what it is made by the normal to the refracted ray. We call this one as an refractive angle. Refractive angle. Correct now? But I don't know where it is connected though. Guys, please do bear with me for 2 minutes, just 2 minutes. Sorry, sorry everyone. Okay. Yes, refracted here, right? Correct now. Now, this is a second ray, this is a first refracted ray. Okay, if it is incident for the second surface, I'm going to call this one as a CD. First refracting surface is A, B. Correct now. Now I'm going to draw one again normal here. Hey, shit. क्या हो गया? लाइन तो अच्छा नहीं बन रहा है इधर. बहुत मुश्किल से कर रहा हूँ. हाँ, आ गया line. Normal. Correct now. Now when it is enter from when it is emerging from the sorry, when it is incident in a denser medium and coming out for the rarer medium, now it will move away from the normal. Correct now. This is what we call emergent ray. But at this condition, this emergent ray is parallel to the incident extended incident ray. देख रहा है ना इधर, right? Here we need to find out it is shifted actually. Correct ना? Exact path से shift हो गया है. This shift in position को calculate करना है. That's why I'm going to draw one perpendicular line for the incident ray here. I'm going to call this one first. This is the incident point P. This is the Q, PQ, R. I'm going to write one perpendicular line QR to the incident ray. This is the shifted distance is there. No, we need to find out how much it is shifted exactly for the extended incident ray to final emergent ray. This is the emergent ray. Correct. Concept is the lateral shift. It shift हो गया lateral. That is what we need to find out. Correct now? Is any doubt up to this point? Okay, let us check one by one. Okay. Now to find out this distance क्या है? QR फाइंड आउट करना है. एक QR फाइंड आउट करने के लिए हमारा पास कुछ भी नहीं है. एक पॉइंट P से एंगल पता है मुझे. दिस एंगल वी कॉल deviation angle, extended incident ray to refracted ray. Correct now? What I will do now from this triangle PQR, from triangle QR, sin इधर डेल्टा है. That's why I will write sin delta. Sin delta कितना आता है? Opposite है QR. Find out this value only QR. Correct ना? Divided by hypotenuse कौन सा है? PQ. Q. We need to find out the value of QR. Then PQ take left hand side. Then it will become PQ is equal to, यार मच्छर काट रहा है आज बहुत सारी. Yes. So PQ sin delta is equal to QR. Correct ना? QR value find out करना था, इतना आ गया, but we don't know the value of PQ. अरे यार क्या हो गया मुझे, right? PQ को find out करना है ना. PQ find कुछ भी नहीं, but we can consider from the point A to point C. This is a slab. उसका thickness I'm going to consider as a T. If I consider this thickness as a T means if I'm going to extend here the normal को ऐसे extend करता हूँ मैंने. Okay, point P है. This point I'm going to consider P dash. Correct now. Now I need to find out this value means PQ value. Which trigonometric function I need to define here. Let me know through the chat box quickly. We'll finish this one very soon. Which trigonometric function we need to choose here. I need to find out the value of PQ. इसको PQ रखना है इधर. हाँ नहीं यार tan होता तो look at it. Tan means opposite by adjacent होता है. Opposite side again we don't know. Correct ना? इधर this side we know. This is an adjacent side. And hypotenuse side को पता करना है. That's why I will define here cos function from triangle. Now from triangle P dash इधर है, Q इधर है. P dash Q. I'm going to define cos theta. Theta value कितना है इधर? R है. Equal to, how we are going to define cos function adjacent by hypotenuse. Adjacent side है ये P dash. Correct ना? P dash by hypotenuse है PQ. मुझे PQ चाहिए था. PQ को इधर से define करता हूँ मैं. PQ will become P dash divided by cos R. Correct ना? P dash क्या है? P dash this length, it is nothing but thickness of this slab. Now look at here. P dash, instead of P dash, I'm going to write the thickness of slab P and divided by cos R. I'm going to call this equation number 2. This is equation number 1. Actually, I need to find out the value of QR. Correct ना? QR है parallel shift in distance. Now PQ चाहिए था at the time. Now we got a value of PQ. Substitute this value in this equation 1. Now PQ का value कितना आ गया? T by cos R. Write down here. Just a minute. Is there any? Yes. Here I have some space. I will write here, guys. First answer क्या आया था? Just look at here. PQ sin delta is equal to QR. PQ sin delta is equal to QR. I will write here. PQ sin delta is equal to QR. But PQ का value पता हो गया हमको. PQ is equal to T by cos R. Correct? Now substitute this value here. Then QR value will be equal to PQ means T by cos R into sin delta. Correct now? Is it right? What I'm writing? This is what the lateral shift. Directly you can write this one as a lateral shift. There is no problem. Or else if you want some more substitutions means few more substitution. Actually, if you look at here means delta function is there. Delta represents that deviation. Either deviation का angle कितना होता है guys? This is the angle of incidence. Sorry. Yes. This is the angle of incidence. Okay. Deviation angle चाहिए तो पूरा angle of incidence minus R means delta value will become I minus R. Correct now? Substitute here. Delta is equal to, actually delta value will become I minus R. Correct now? Substitute the value here. Then it will become QR is equal to P by cos R into sin of delta means I minus R. Correct? This is also an equation for lateral shift, or else or else we can write like this also. QR is equal to 1 by cos r is there now. Let me know what is the meaning of 1 by cos r, or which trigonometric function will become under 1 by cos r. Quickly, quickly. One more minute I will take. Secant. Yes, excellent, guys. We can write this one like secant r t into sine of I minus r. This is also an expression for the lateral shift. Yes, Akbar, right. Guys, this is all about today's class. Thank you so much. Okay, in next class onwards, we're going to solve the few good numerical values, which is based on the refraction, and also few good concepts also there. It may be as, which might be definitely the question will be arising from that part also. Okay, concepts. I will explain that one. Okay, in actually our next class will be on Thursday. Correct now? If tomorrow is holiday means. Okay. Thank you for attending the class, guys. We'll meet you in our next class. Okay, if you want to note down, means note down. 2 minutes I will be here. Okay, or else take screenshot, or else I will send this one in a as a PDF to your respective group. Just you ask the person who is there. Actually, in Ballari, Sanjay is there. No, just you ask if you want the notes means, or else if you are already having a notes means there is no problem. Okay, okay, guys. Thank